Welcome back. In this video, we're going to be working on solving rational equations. And so the first thing to know or to remember is the difference between an equation and an expression. An equation has an equal sign in it, an expression doesn't. So specifically a rational equation, you can see the examples shown here, 1/2 x plus 1/3 x plus a half equals 1/5. There's an equal sign in it. And the same is true for all of the other equations shown there in blue. In contrast, the writing shown in green, you'll see that none of those contain an equal sign. Those are expressions. Remember that an equation has a true or false value depending on what the variable is replaced with, whereas a equation or an expression does not have. In this section, we're going to be working on solving equations. So our answers are going to be numbers that make the equation true rather than just simplified expressions. Okay. The overall procedure for solving a rational equation is we need to first check and acknowledge any possible values of the variable that would lead to a zero denominator. Those end up not being solutions, and so in the course of our work, it may appear that they're solutions, but if we note right away that they are not, then we won't make the mistake of claiming that they're solutions. So check and see, okay, what values of the variable are going to make the denominator zero? And then we'll just remember those for later. We're going to find the LCD of the denominators in the equation, even though we're not necessarily going to add or subtract anything. But we're going to find the LCD. Then in step 3, we're going to multiply both sides of the equation by that LCD. And if we do that successfully, there shouldn't be any fractions left. And once we've done that, we can solve the equation using methods we've already studied. Once you've gotten that done, then we'll check our answers just to make sure that we haven't messed anything up. Okay, and once again, as a reminder, in this section, the answers here are going to be numbers that make the equations true rather than simplified expressions. All right, so the best way to see how this goes and to get good at it is with practice. And so let's try. So taking a look at this equation, 1 over x plus 2/3 equals 1/5. In this one, I can tell you right now that x can't be 0, right? Because if x were 0, we'd be trying to divide by 0, and that's forbidden, right? So x is not 0. Okay, so now we need, our next step is to find the LCD of the denominators that we have here. And that's 3 times 5 times x, or 15x. So the LCD is going to be 15x. So I'm going to multiply both sides of this equation by 15x. And our reason for doing that is to make it so that those fractions go away. So let's see. I'm going to distribute the 15x into our left-hand side. The right side, we're ready to just go ahead and multiply. 15 times 1/5 is 3, so there's 3x. On the left side again, the x's will cancel, leaving with 15 and no x's. And then 2/3 of 15x is going to be 10x. Okay, so at this point, our fractions are gone, and that's what we needed. And so we're going to solve this equation as we would have earlier. So let me subtract 10x from both sides, putting in x's. Okay, it looks like x is negative 15 over 7. So that's our solution. It didn't end up turning out to be anything like the 0 that I told you it couldn't be. So that's fine. It looks like negative 15/7. Okay, all right, let's try that again. So here we have 1 minus 2 over b squared equals 15. Sorry, 1 minus 2 over b equals 15 over b squared. So again, we know the b is not equal to 0. And this time our LCD is going to be b squared. So we're going to multiply both sides of our equation by b squared. Okay, and then as before, let me distribute that b squared into our left-hand side. That will give us b squared minus 2b. And then on the right side, 15. This one's kind of interesting because we ended up with a quadratic equation. And so we'll have to factor here and see what we get. So it looks like 5 is going to be a solution and -3 is a solution. So remember our answers here are numbers. They're -3 and 5. Okay, so let's try another example. For this one, why don't you take a minute and try it yourself, and then I'll pause the video, try it yourself, and then restart it and see how you did. All right, so here taking a look at the equation, I can see that x can't be 1 because then that would make the denominator on the left side 0, and x can't be 0 because that would make the denominator on the right 0. And so those are our two exclusions. The LCD for the denominators we have is going to be 3x, x minus 1. So I've started out multiplying both sides by 3x, x minus 1. And so on the left side of the equation, the x minus 1s will cancel out, leaving 3x. On the right side, the 3x's will cancel out, and that will leave just the x minus 1 factor. So that cleans the equation up rather nicely. So let's finish by distributing to remove the parentheses. And so it looks like our x will just be -2 for this one. Okay, and that was neither of our exclusions, and so we're all finished. Okay, make sure that you're able to get -2 out of that. If you don't and can't figure out why, let me know, and we'll figure it out. Okay, here's another one to try. This time there are 3 terms, so there's a little more to do. What you'll want to do is factor that denominator that is on the right-hand side and go from there. So to begin with, we can tell that x can't be 1, x can't be -1. And if we factor that right side, we'll have 1 over x plus 1, x minus 1. And you can tell looking at that it's got the same exclusions as before. So again, pause the video and try to solve this equation and see what you get. All right, so the LCD here is going to be x plus 1, x minus 1. And so we're going to multiply both sides of our equation by x plus 1, x minus 1. So you can see down below I have done that. And in the next step, we'll distribute here into our sum on the left side of that LCD. For the right side, x plus 1, x minus 1 is going to cancel with both factors of the denominator on the right side. That will end up just leaving us a 1, which is kind of nice. On the first fraction, we'll have x plus 1 dividing out. In the second fraction, we'll have x minus 1 dividing out. So we'll be left with 2x minus 1s plus 1x plus 1s, and that will equal 1. So here our fractions are gone, and so from here it should be not too bad. So we'll have 3x minus 1 is 1, 3x is 2, or x is 2/3. Okay, so our single solution here is going to be 2/3. All right, so a couple more examples. So for this one, our exclusions are going to be -5, and 1. And our LCD is x plus 5, x minus 1. So then, as before, we'll multiply both sides by x plus 5, x minus 1. And then the amount of work that you want to show here depends on just your comfort level in part. If you are confident in skipping some steps, you're able to. In the last example, I really showed the distributive property in here. If you don't feel necessary, then you can leave that out. Here, the 2 times x plus 5, when we distribute, the x plus 5s will cancel. We'll be left with 2 x minus 1s. And then for the second fraction, the x minus 1s will cancel. We'll be left with 1 x plus 5. On the right side, we'll have everything still, x plus 5 and x minus 1. Okay, so that takes care of all the fractions as before. So then we're going to just solve the question as it sits, or equation as it sits. Okay, so I've distributed to remove parentheses on the left side. And then on the right side, we've multiplied out the product of the two binomials. Okay, so then simplifying the left side separately, we'll have 3x plus 3. Right side, nothing is going to happen now. So I'm going to collect all of the terms onto the right side so that I'll get a quadratic polynomial that is set equal to 0. We'll factor, we'll use the zero product property. And that doesn't look good. So let me go back and check over my work. One moment. All right, so sorry about that. So what has happened here is I wrote the problem down wrong. And so I wanted to talk about a couple of things here. First of all, sorry about that. And how did I know that something was wrong? Well, I had gotten to the end here, and I'd gotten down to a polynomial that I wasn't going to be able to factor. Here, two numbers that multiply to -8 and add to +1. There aren't any integer solutions to that. So that told me something was wrong because at this stage of our learning, we have all of these problems are rigged in such a way that you're going to end up with something here that factors. Later on, as you study more algebra, you'll get to learn how to solve more equations like this one where they don't factor. But this one, all these rational equation problems are set up so that they will factor. So if you have something like that happen in this kind of stage of our learning, then that means one of two things happens. Either you did as I did here, wrote the problem down wrong in the first place, or there's some sort of a error in your work. So if you get to the point at the end where, okay, it just won't factor, then double check and make sure you wrote the problem down right in the first place. And then additionally, double check all of your steps. So I checked all my steps, and then I looked and I figured out that I wrote the problem down wrong. So sorry about that. But anyways, it was just one small change. Instead of a plus sign in the middle, I should have had a minus sign. So let's go ahead and rework that with the minus sign, and we should see this come out much more cleanly. Of course, a lot of the steps are going to be the same. We know that our exclusions are -5 and 1. And our LCD is still x plus 5, x minus 1. So I'm going to multiply both sides by x plus 5, x minus 1. And then when we cancel in the first term, we'll be left with 2x minus 1 minus this time x plus 5. The right side will be the same. And so then we'll have 2x minus 2 minus x minus 5. And so then simplifying the left side, we'll have x minus 7. The right side, x squared plus 4x minus 5. So then collecting all the terms to the right side, we'll have x squared plus 5x, or rather 3x, and then plus 2. Okay, and that looks a lot better. We'll have x plus 1, x plus 2. Okay, and that factored, right? So that tells me I'm on the right track. So here it looks like the solutions are -1 and -2, but I should go back and look at our exclusions. One of our exclusions, nope, we're okay. It was -1 and -2. I was thinking of a positive one. So we're actually okay. It's -1 and -2 for our solutions. All right, so that will do it for this part of our look at solving rational equations. I do have some more examples to come, but we'll stick those in another video. Okay, in the meantime, let me know if you have any questions, and then have a great day.